guys, I've missed you. Today we're going to do a little bit of notes on the properties of gases. So open up your notebook and find something to write with, because today we're going to start by drawing a table in our notebook. So today's lesson is all about the kinetic molecular theory. So what I want you to do is draw a table like the one you see on your screen. It's just kind of like a box with 4 different quarters, and then in the middle is kinetic molecular theory. Take a couple minutes, get organized, and do that. You could pause the video if you need to. Okay, so now that you have your little table set up, what we're going to do is this. We're going to kind of go through all the properties of a gas, and then I just want to demonstrate to you what they look like, and then we're going to talk about the proof that you can find in the everyday world that supports this idea. So just looking at this quick demonstration of what gases look like, you can already predict a bunch of things about how they behave. So the kinetic molecular theory tells us 2 major ideas about gases, just 2 principles. And these are things we take for granted all the time. So principle number 1 is that our gases are moving fast. Like, look at the video. They're moving so quickly. So they're moving very fast, and that gases tend to be as far apart from each other as possible. So number 1, gases move really fast and with a lot of energy. And number 2, gases try to be as far apart from each other as possible. So taking a look at the kinetic molecular theory then, each one of these boxes is going to be represented by the fact that atoms that are gases move very fast and are very far apart from each other. So I have a couple ideas for us to demonstrate a way for you to see that gases are fluids, gases have low densities, gases are highly compressible, get that out of the way, and that gases fill their container completely. So take a look copy that into the boxes, and then take a look at these examples that I want to show you for today. So this is a simulator, and this simulator is going to demonstrate for us just how our gases behave. So gases move really fast. Gases completely gases are very far apart from each other. So number 1, gases behave like fluids. So let's see what that means. When a gas behaves like a fluid, it really just means that that gas is going to flow out of a container. The same way that a liquid will flow out of a cup and into a beaker, or out of a beaker and back into a cup. Gases flow the same way. If you've ever looked outside and seen a factory where there's like big smokestacks and the clouds of smoke are just flowing down the side, then you've seen this in real life. But I'm going to demonstrate it to you right here again with this simulator. So we'll just pump a little bit of gas inside. You can see the pressure going up because there's more gas going in. The first thing we're going to see right away is our gases move really fast, and that they're going to try to fill out and be as far apart from each other as possible. And in order for them to spread out and be as far apart as possible, if we open the container at all, just like a container filled with water, a container filled with gas will spill. And we can see it start to spill out, that those gases are going to spill out of that empty space, just the same way it would happen if we poked a hole in a water balloon. All of that water would flow out, all the gases would flow out as well. So gases are fluids just like water. Okay, let's reset. Another example that we had on that chart is that gases will completely fill their container. So because gases are very far apart from each other and they move very fast, they want to spread out as much as they can so they bump into less stuff. And so if we fill it with container, you can see right away that as our gases go in, they're going to spread out to fill as much of the container as possible. And so after just a few minutes, you'll see that the gases end up evenly distributed throughout the entire space. That's important. The fact that gases completely fill their container is the only reason that you and I are breathing right now. That there aren't spaces in our home or outside in which you can't find any oxygen, because our oxygen gas molecules are spread out as far as possible. And luckily for us, that means that we always have access to oxygen to breathe, because no matter where you are in this in this earth, our atmosphere keeps all of that oxygen inside for us, and we're able to breathe it wherever we go. See, perfectly filled throughout. Okay? Our next example is that gases are highly compressible. So because our gases spread out as far as they can go, even if we put a lot of gas in our container, turns out that our gases are compressible. Watch this. We can squeeze them. Did you see that? Now, eventually our pressure built up a little too high and it exploded, but you get the idea that we can contain our gases. We can smush them closer and closer and closer together. Now, we've seen that happen before. Have you ever tried to squeeze a balloon? Or if you have like a big coat and you try to pack it into your suitcase, you can squish out all the air, vacuum seal something. That's because what we can do is we can compress that gas into a much smaller space. Okay, and then our last example, so you should be filling these in on here along with me. Our last example is that our gases have very low densities. And what we mean by low density is that we mean that there's a very small amount of stuff trapped in a big amount of space. So if you've ever blown up a balloon with helium, you know that that's true, that it's going to float in air. You know that if you've ever held your breath underwater, that you start to float up a little bit because the gas that you breathe in and out is a very low density. There's very few atoms in a large amount of space. And that's your kinetic molecular theory. So again, 1, atoms move really fast. 2, atoms are really far apart from each other. And these are 4 really great examples of how we see that every day. So that's it for today, guys. Just go ahead and take those notes down, write them in your notebook, and that's really all we have planned for this afternoon. So take your time reading over those things, and then when we get into next class, we'll start to talk about how do we measure these properties of a gas? How do we measure them? So we know that they exist, but how do we actually take data and make some predictions using the properties of gases? All right, talk to you guys soon. Bye.